The facade pattern is a structural design pattern that provides a simplified interface to a complex system, encapsulating the complexities of multiple subsystems into a single unified interface for clients. So say that we have an e-commerce application that allows users to submit orders. Here are the steps involved in that process. So we have a user that is submitting an order, and then we have a server which has multiple steps for handling this order. So first of all, we have to authenticate the user, check inventory, so make sure that we have enough of the items that the user wants to purchase. We then connect to some payment service such as Stripe. We then fulfill the order, which might involve something like reducing the inventory, and then we charge the user and send them a response, which can either be successful, or if any of the steps fail, then we can send some sort of failed response. So as you can see, there are 5 main steps involved in processing an order. So let's first of all implement this roughly in code. So I've created some classes to simulate the steps involved in processing an order. So let me show you what we have here. So we have an order request class, and this is going to be the request object containing the user's submitted data. So say that the user has some form, they enter their name, their card number. We also send the amount for the order, the address of the user, and the item IDs that the user wants to order. Okay, so this is like the order request object. We then go through some authentication steps. So I've just created an empty class for now to keep things super simple, but this might check the user's session, checks whether the session is valid, that their username all checks out. And then we have an inventory class with a couple of methods, so we can check the inventory for the item IDs, and we also have a method which can reduce inventory by a certain amount for the specified item ID. Okay, so and check inventory, we're just going to return true, so we're always going to say that we have an item in stock. And then we have a payment class for handling the payment step within the order process, and here we can set the name, card number, and the amount that the user owes for the order. And then we have a method called pay, which is going to simulate maybe connecting to some payment service and charging that user's card. And then next up we have an order fulfillment class, which is going to check the inventory, that we have sufficient inventory. So we can see here we have a fulfill method, which is going to loop through the items in the item list, so the items that the user wants to use, and it's just going to reduce the inventory of those items in the loop. And we also have, we've also logged inserting the order into the database, so that we have record of this order in our database, a sort of permanent record. So these are just sort of classes that are simulating the steps involved in the order process, just sort of some rough code that we can use to sort of demonstrate this example. So this is now the sort of important bit. So I'm going to show you how a client would actually use this solution. So first of all, we can create an order request object, and this is going to be equal to a new order request. We can then create our authentication object. We then need to create our inventory object. And in here, what we can do is we can loop through our order request item IDs. So you can remember in our order request object, just for convenience, I've sort of hard coded these values in. Obviously a real order request wouldn't have these values hard coded in. I've just done that for convenience. So what we can do is we can loop through all of the item IDs in the order. So we can say order request dot item IDs, and then we can check the inventory for each item ID. And this is always going to return true, so we don't have to worry too much about that. This is just a quick rough example. Then we can create our payment object. So we can say var payment equals new payment, and in here we can pass the some information from the order request object. So we can pass the name, the card number, and the amount for the order. Okay, then we can call payment.pay. And finally, we need to do the order fulfillment. So let's create our order fulfillment object. And this should be lowercase. And in here, we just need to pass our inventory object. Okay, then we can call order fulfillment.fulfill, and we can pass the some information again from the order request object. So then we pass the address, and finally the order items, so the item IDs. Okay, so that's everything that we need to do for processing an order. Okay, so let's run this program to see that everything is working correctly. And we can see that we are charging the card with the name Danny. We insert the order into the database, and we are reducing inventory of all of the items that the user has ordered by 1. So we are fulfilling the order. So as you can see, every client that needs to make an order has to go through all of these steps to make a single order. So you can see here, every time we want to make an order, we have to go through all of these steps. And every client that needs to make an order becomes coupled to or dependent on 4 concrete classes: the authenticate class, inventory, payment, and order fulfillment. So if we had 10 classes that needed to make an order, then we'd have 10 classes dependent on these 4 classes. So that's a lot of coupling. So if one of these 4 classes changes, then that's going to be 10 classes that need to be updated. And this is not good, this is not maintainable. So each client that needs to make an order will depend on 4 classes. So here's the client, it's going to depend on these 4 classes. So let's now take a look at how we can solve this issue using the facade pattern. So clients making an order don't actually care, or they don't actually need to know about the steps involved in making an order. They just want to make an order. So let's introduce a new class called order service with a single method called order that abstracts all of the logic, so that all other classes that need to make an order only have to depend on this one class. So you can see here we've created an order class which has an order method that accepts an order request object. Now this order service class depends on these 4 classes, which are the sort of steps involved in making an order. So this order service is essentially containing all of the steps that we had here, all within this one method. So that now, all classes that need to be able to make an order only need to depend on this one order service class, and not all of these individual sort of steps involved in making an order. So let's now go ahead and make our order service class. So this class is going to act as our facade that encapsulates all of the complexities and steps involved in making an order. So clients can then make orders without having to know about all of the details or steps involved in the order process. So let's create a single method called order that takes an order request object. And in here we can simply go through all of the steps in creating an order, and these are actually going to be exactly the same as what we have in our client over here. So let's copy and paste those in. Okay, so this is everything we need to do to make an order, and now inside of our client we can remove all of this stuff. So all we need is our order request object. So this is our sort of incoming order request from the user, which contains all of the user's sort of inputted data, such as their name, card number, address, etc. We can then create an order service object, and we can then call order service dot order, and quite simply just pass this order request object. And now that's all we need to do to make an order. So let's run this and we should get exactly the same as what we got before. So we can see here exactly the same as what we had previously. So now clients can make orders without having to depend on many classes, and without having to know about all of the complexities involved in making an order, as all of these complexities have been abstracted away and encapsulated within this order service class. So now you can see it's much more simple for clients to make orders by using a Facade class.